Welcome back. Another episode of Conversations in Artificial Intelligence. Paolo, your host, and today we're going to address an interesting topic, which is the borderlines of artificial intelligence and blockchains. So what we're going to talk today is basically how the consumers of algorithms and the producer of algorithms will work together in the future world. And with us today, we have Jean-Philippe Beaudet from Montreal. How are you?
Very good, very good. Thank you.
So how did you get involved into AI?
Well, it came much as a surprise for me. I have learned AI from the scratch. So to be quick, I did not go to computer science school. So I was recruited by a friend when I got out of video game programming school, which is a bit out of context. And for him to say, I need a coder and I need to do some stuff. Are you able to read Google stuff? And I said, yeah. And so I just said, okay, what is it? He said, oh, it's machine learning. I didn't knew what machine learning meant. If I knew, I would probably not have gone into it at the first place. And I just learned stuff. So then I learned about to do NLP, to how to treat language, how to understand language, and I became pretty much passionate about it.
How did you get involved instead with the crypto blockchain movement?
Well, that was different. And so when I was recruited in my first startup, by the way I just described, it was called Serenity Technology. It was a service providing firm, and the offering was to do CTO for hire. So it was for people who lacked very advanced technical knowledge and needed to build their awesome new ideas and projects. So we were doing that for clients for mostly 4 years. And as you know, startups are always small. So we used to go to free offices. And one of these free offices was called the Bitcoin Embassy. Was the first place of this type in Canada. It was a hub to evangelize and make people understand what is Bitcoin, what is this mysterious and cryptic blockchain, and why do we call this crypto? So they needed help. They needed help in programming, and so I decided to help them. And the same way as with machine learning, I didn't know anything about cryptography, tokens, coins, or anything like that. I just learned on the spot and helped them to install this Bitcoin selling product. So it's you buy and sell Bitcoin. Very simple, but it was pretty new at that time. So this is how I discovered blockchain. It took me a few months, more than for machine learning, to be truly honest, but I got to it.
Montreal, as far as I know, is kind of the center for machine learning innovation in Canada. Tell us a little bit about this. What's going on? What is the startup community like there?
Well, it's we have some luck. There was a big advancement in machine learning in the last years that a lot of people heard, and I'm pretty sure that you discuss it pretty often. They call it the deep learning. Now it has spanned up a few other branches, such as reinforced learning and adversarial learning and all these subcategories. But the inventor of these new approach were based in Montreal, and one of these is still teaching at the University of Montreal, Yoshua Bengio. So he's kind of a role model for a lot of people here as to we can do it too. I come from a country where it's not like Silicon Valley. There was no big startup community. A technical startup community was at its infancy at best here. But at the same time, when this deep learning rush arrived, a few wise and quick people in Montreal said, hey, it's the time to start something. So now most of them are working at Silicon Valley or in China, but many of them still remain in Montreal and are still trying to attract more companies to stay here. Even the country did try to make it attractive by doing good research and development incentives, but sadly, as with many other industries, is generally only the big player that can profit from it, such as Facebook or Google that opened labs here. So the fact is people cost less. There's a good corporative environment for research here, so that helps. And at that point, a lot of accelerator started to pop on. So all these incubator, accelerator, VCs that wants to see, okay, there's amazing project coming out, but it became difficult. And from last year's and big investment in the AI have diminished. So the amount that are invested have not diminished, but the number of investment have diminished. So it becomes much and much harder to raise for AI company here if they don't have a very good track record of previous success.
Why don't you give us like your take about what's going on 360 degrees in the enterprise world?
Well, we know very well for the person that it's an easy thing. People give their data freely because they want to have what they call a free service, which is not free because you give your data for it. So for now, mostly on the corporate side, it's always about the first thing you think when you want to do a new model, saying, okay, we need this capability. It wants to be automated. The first question you ask yourself, okay, where do we get the data? And then how do we analyze the value of this data? What do we do with this data to construct the best model? And how do we reduce the bias and assumptions we have? And it's always the same process. It starts with data. Then you can have some capability. So there's a relation between those who develop a new capability with machine learning and those who owns the actual data that can be used either to train this new model or either to use it. So in this way, when you are doing a new company in AI, your first strategy is, okay, do I already have the data? Yes or no? If not, or if so, where do I get the data? In which state I'm going to have this data? And then after you go to more technical requirements of, okay, how much performance do I need? Are we going to build this model and how it should be used or how it should be accessed? So it's a large thing and it would not be easy to just describe all the instance of how you can capture data. But generally, you end up with the same thing. You either have structured or unstructured data. Unstructured data comes in any shape, size, format. It can be complete garbage up to very, very precious data, but it will not follow a specific schema or a specific structure. So you have to mine this data to make sense out of it. Then you have what we call structured data that is generally dubbed to be a database. Doesn't have to be a database, but it will follow a specific structure and it can be queried and played with using this structure. This is the normal landscape for AI. Then when you are a company, let's say you are a company that owns your Amazon, you owns data about 100 million user, you have their credit card, you have their habits, you have what they want, what they are looking at, how much time they are getting into which space in your commercial virtual space, and you have a lot, incredible lot of data about them, and you want to use this new algorithm that you did not develop in-house. And on the other side, you have this little group of geeks or this little lab that has produced this new model that has more performance or can get information faster or can even pilot a spaceship for that matter. There's almost no limit to what we're going to be able to do in time. You have this model, so you need data to use it. So let's say that your model concerns sensitive data. The best example and the one we are working on right now is for medical data. You have pharmaceutical that wants to develop new medicine. They want to do it faster. They want to reduce human trial. So they know that with machine learning, it's able for them to save tremendous number of time because these machine learning can pre-filter a lot of results for them, which makes them go faster to the market. And we're speaking about billion-dollar projects. But at the same time, the data that you need to produce or to use this is completely private. It has a specific private impact on these people, either on their work opportunity, either on their insurance cotization, or just because it is their private matter, it is their own health. So how do you protect these highly regulated data with a sudden firm there that is just four guys that has produced this super AI? And you have a problem because the people that owns the medical data don't have the legal right to share this data. Sometimes they can make partnership with government, and they can have exceptions in which pilot project and small project will be authorized under the supervision of some of these government instances, but usually for the market it's just not possible. So the reason why medical AI is so much hindered now, it's not because there's a lack of researcher. It's not because there's a lack of data. It's not because there's a lack of will. This is one of the biggest AI markets coming on with the IoT. The problem is, how do you deal with this conundrum in which the medical owner, the medical data owner cannot give you the data? So then they have to ask you for the algorithm. But the algorithm is an algorithm. It may have cost a tremendous amount of money or time to produce, and it is IP. So you don't have the right to protect your investor or to protect the people that have put money into your company. You don't have the right to just give your IP like that. So what do? One of the two parties must trust the other. And this is a big problem. Each time you have to find an agreement, you have to find big contracts and NDAs that doesn't protect much, because the one who has the most economical power will always win in such instances and stand out.
In the last few years, we have seen the emergence of services like, Amazon Compute, the Microsoft Azure. These services, they have 3 levels of security, so they have password protected. Why is that not good enough today in some sector?
Well, because at one point you will need to put all your data on this either Microsoft or Amazon or any other structure for that matter to use your data on their system. And all these have terms and agreement generally in which it does not guarantee protection to your data. So you will need to have an insurance in which you can say, okay, I am the owner of medical data in the jurisdiction of Canada, and I have enough guarantee so that it's going to be regulated for me to put all the hospital server data into Microsoft Azure. So it is still a complicated thing. So it can work for some company, but it doesn't necessarily fix the problem, because this is not a marketplace. It is not a place where the algorithm seller can say, okay, put your data into this place and you can use my algo, but I have insurance that you can do nothing else with my algo, and you have insurance that I have never access to your data.
Can you give us, if you know, like some measure of the actual costs of data breaches for these industries?
Yes, well, we have made research on this. It is hard to find as data. What we have come to know is that in Canada, in a general sense, on the average, it costs $10.6 million to a small Canadian company when they get hacked. But this is a national average, so that doesn't really count for the actual thing, because if you're a small company, it may cost you 1 million, but if you're a big government agency, it could cost you billions. If we can go on to a more precise case, let's say we could say the Marriott Hotel. They lost more than 50 million IDs, and as they were an hotel company with their private clubs and premiums, and they had the passport of these people. So when they got hacked, they could not know which passport has been compromised and which didn't. Maybe none of them has been compromised, maybe all of them has been compromised, but to not take any chance and to do a good PR, they decided to replace all of them. So it has cost an average of $30 billion, which is a lot of money. So imagine the number of people you must put to redo that, to accompany these people, to push them to say, look, you need to do that. We're going to pay it for you, but still they need to do it. So the number of PR and communication they had to do must have been, well, I would not have wanted to be in their boots at that time.
So what are then the possible solutions to this problem?
Well, there's a lot of possible solutions. For now, none of the proposed solution has taken the whole market share. So there is one approach that has been proposed a few years back, and that has worked very, very hard for the moment. It is called homomorphic encryption. So homomorphic encryption is a new way or protocol, we could say, to encrypt data, which has a very, very particular feature. This feature means that the machine with the right mathematics can read the data without the data being clear. So well, to try to explain it simply, with using some mathematical equation, they can make sense of the data without decrypting the data. So it means that, let's say you send me some data that is fully encrypted on my server, and I have this super algorithm that I can run on it. My algorithm will use homomorphic encryption to read your data without me having any keys of any sort to read it. Somehow the machine is able, with some small secret, to decipher it without having the encryption keys. It is not very intuitive. It is a very complex technology, but for now it doesn't fit the solution because it is not performing well. It is still very slow, and it is still only able to deal with some type of variables. So to give an example, it is not yet or barely able to deal with floats, meaning non-integer numbers. It is barely able to deal with text. So point being, it is a good path. It will get better, and some people, some very serious people, such as Adam Trusk, which is working on open mine infrastructure. He's doing very, very interesting work on this. Singularity.net has the intention of using homomorphic encryption to create their privacy environments. So everyone is looking at this solution, but it is not yet ready. Another solution that has been proposed are fully centralized systems, such as what you say with Microsoft Azure, with the IBM Watson environment, and all these environments. They are made as centralized point of control that has these big labs and big security, physical security there. So what they're going to try to say is, look, the guarantee is you have all my quality insurance that the data will not be compromised. But still, it doesn't fix the problem of transmitting data, and it doesn't fix the problem of terms and agreement and knowing that your data will never be used by a third party, and that it could not be snooped upon while you are sending it to, let's say, Microsoft or to this new cloud and to Amazon or DigitalOcean or any other provider for that matter. We have to see here that is often when we speak about blockchain, people wants to figure that it is an entire solution. Blockchain, in this case, can only fix part of the problem. And so what is special about the distributed ledger and blockchain? The real special thing about it is the unicity. So what some people like to call the immutability of data. So to make it very simple, when you have distributed ledger or blockchain, everyone is sharing the exact same set of data, and with some cryptographic magic, they can always confirm to each other that they have the exact same order, the exact same data within the exact same time frame. And if someone goes out of this, it becomes rejected from the system. So this is called, in simple way, this is called a consensus mechanism. It doesn't guarantee the truth, but it is what we have as nearest from determining the truth. It's the truth by the majority, we could say. So blockchain has created this concept of unicity and transparency. So you can now prove that something digital has happened or has this state or is this way within this time. It seemed innocuous, but it is very important. So when it comes to data privacy, what you need, it's not only to hide the data, you need to prove that your data is the right one. You need to prove that it has been transmitted and that it has not been snooped upon. You need to prove that Mr. A and Mr. B agreed for this, but that nor Mr. A or nor Mr. B has access to the other's asset, meaning algorithm or data. And so what we have seen with the blockchain is the ability for people to trade assets from a peer-to-peer position, meaning that I can send you something on the blockchain, which would generally be considered as a token or an asset of data, and I can be sure without using any other one, any other party, or any other trusted person, you can be sure, and I can be sure that I sent it to you. So this create the possibility of creating escrows. I like to call them escrow. I know that escrow is generally the concept of I give money into the escrow, and when condition A, B, and C is good, the money is triggered to be released to Mr. X or you. So you can create conditions in which money is going to be transmitted to someone or another, but it doesn't have to be money. An escrow can be taught for data too. So you can have data that is stored, but that will only react to some specific triggers. And that these triggers are mathematics, they are smart contracts, they are not humans. So they cannot make mistake, they cannot be corrupted, they cannot forget something. The worst that can happen is they have a technical bug.
Do you envision that there is a full solution in the horizon, or you think this is still far from coming?
It's a hard question. I think that Singularity.net is doing a good job for now at creating this infrastructure layer in components, if you prefer, or SaaS environment in which people is going to be able to leverage this technology to fix the solution. But in the short term, I think it's more like there's a new business opportunity that has been created in which someone or many people needs to arrive with a service that could be pretty simple. So some centralized service could be pretty simple to say, okay, I am the escrow between some people that needs to sell data or host data, mine data, do transformation on it, and others that wants to sell capabilities of an algorithm that needs some specific inputs into it. So there's a business opportunity. I don't see that a lot of people have gone into taking this opportunity because the data market is still new. A lot of people don't know yet how to tackle all the challenge that makes the data being siloed. Because the reality for now is that most of the available data is not used because of all the reasons we stated before. So the business opportunity for now is to create this equivalent of an escrow. I truly believe that blockchain can help. When we were working on VNet, we have developed a vision on how to create this middle ground between the seller and the buyers, and that this middle ground responsibility will be to give guarantee that security is respected, that legitimacy, ownership of data is respected, and IP is respected, that transaction can be verified, confirmed, and that are protected by consensus. So we need to have a system in which you can build trust, because you cannot play with this data, you cannot get it wrong.
As our time comes to an end, I'd like to ask you one last question. So who do you think are the startups that should pay attention to this problem that, in their process of growing might hit this type of barrier, and then that might constitute like the data privacy or the inaccessibility of data might constitute a reason for them to fail? Where do you think?
Well, all the startups that are in European Union has to face the GDPR. So to start with, they have to understand how they're going to store, how they're going to capture, how they're going to use, how they put their terms and agreements for the data, because GDPR has real legal implication. You can get accused with that, and you can have to pay very severe amount of fines if you get caught. So already everyone who is dealing with personal data in Europe has to ask themselves the question about privacy from the get-go. Then if you want to be more precise, all the startups that will work with medical data and financial data will be the first to be checked upon, because they're the most heavily regulated environments. And so everyone that is dealing in medical data has to understand what compliance means, has to inform themselves about, okay, this or that country or my country is dealing with the medical data this way. So they will all have to face the challenge. And for now, sadly, we all have to come up with a custom solution, a solution that respect the current law, but is not a generalized infrastructure. And this is what is lacking for now, is a more a more generalized tool that is agnostic to any specific case, but that can give you the ability of creating privacy. So for now, it's a case-to-case handling. So every time you have to say, okay, we're going to ensure for our security, we're going to ensure for a point of acquisition of data, we're going to ensure that our data mining is well done, that we can erase every left data out there. But you have to prove a lot of things manually for now. You cannot just say, okay, I'm going to go into this nice project that's going to give me all these guarantees.
Very interesting. Jen, our time came to an end. So for our audience, it is an honor privilege to have you here today. If you have more questions, this is a very interesting topic, but also one that will affect especially the B2B relationships in the years to come. And it's one that is not very much talked about. I'm very glad that we covered it with JeanPhilippe today. And JeanPhilippe, thank you so much. It was a great pleasure having you here.
Thank you very much. It was a pleasure. And if any time you need to do a follow-up on this question, I'll be more than pleased to do it.